Okay, the topic is dynamics. This is the part of the AS physics. So first of all, we have to learn about the momentum. Look, if this is the object, its mass is suppose 7 kilogram and it's moving with speed 20 meter per second, 20 meter per second velocity speed. And there is another object, identical object, the same mass, but moving with the velocity 10 meter per second. Both objects collide with this glass barrier. Definitely, this first one will show more destruction. The intensity of the collision will be large for this object, and for this lower one, it will be small. So it means the intensity of the collision or quantity of the motion depends on the velocity. So the quantity of motion in an object depends on its velocity. So from this experiment, it is very clear that the quantity of the motion depends on the velocity. Larger the velocity, greater the quantity of the motion. And similarly, if this is the object of mass 7 kg, it's moving with velocity 20 meter per second, and this is the object of mass 20 kg, moving with velocity 20 meter per second. Velocities are same, but the masses are different, and the both are going to hit a glass barrier. Definitely, the larger object, the greater in mass, will show the more destruction in the barrier. So the quantity of motion also depends on its mass. Quantity of motion of any object also depends on the mass of the object. So quantity of motion, number one, depends on the velocity. Number two, it depends on the mass of the object. And this property, this quantity of the motion, is called momentum. So the momentum, a physical quantity, it depends on the mass of the object. Number two, it depends on the velocity of the object. So we can write momentum is the product of mass and velocity of the object. So it's a physical quantity which depends on the mass, which depends on the velocity. So it's a product of mass and velocity. Momentum is represented by capital P. So M times V. M is the mass, V is the velocity. Now the unit, this mass measured in kilogram and the velocity in meter per second. So this is the base unit, SI base unit of the momentum. Now momentum is a vector physical quantity because it has fixed direction, and that direction is similar to the direction of the velocity. Velocity is a vector, momentum is a vector, so the direction of the momentum is similar to the direction of the velocity. Now, when the graph is plotted between mass and the velocity, then the area under the graph is equal to momentum. So momentum is the product of mass and velocity, mean velocity suppose at the y-axis, mass at the x-axis, then the area of this graph will be the momentum. Look, there is a change of velocity. We cannot maintain the velocity all the time. So we have to change sometimes, number one, due to increase in the magnitude. Velocity changes. Number two, due to decrease in the magnitude. Velocity changes. And number three, due to change of direction. Velocity changes. So these are the three methods, simple method to change the velocity. Number one, by increasing the magnitude of the velocity, by decreasing the magnitude of the velocity, and by changing the direction. So when the velocity changes, acceleration produced, and the momentum also changes. So due to change of velocity, we will write change of momentum. So this is the one of the method to change the momentum. Change of velocity will produce a change of momentum. We can change it by changing the mass. We can change it by changing the both mass and velocity. But here in the dynamics, we have to discuss only the change of momentum due to change in velocity. Now, according to kinematics, acceleration is equal to change in velocity divided by time. So this one, this acceleration times t is equal to change of velocity. So we can write here the change of velocity m times a times t. So the change of velocity is equal to ma times t. So the change of the momentum, this is change of momentum, is equal to this ma. And do remember, F is the force, which is the unbalanced force. The force which produces acceleration is unbalanced force into T. It means the unbalanced force and time product is the change of momentum. So the Newton for the force and second for the, so the momentum SI unit or the change of momentum SI unit is Newton second. So Newton second is the SI unit and kilogram meter second power minus 1 is the base unit. Now this equation can be written as unbalanced force is equal to change of momentum divided by time. Now from these two relations, number one and number two, from the number one, if the graph is plotted between the time at the x-axis and the force at the y-axis, then the area of the graph is change of momentum. And from this graph, if the momentum is plotted at the y-axis, time suppose at the x-axis, then the gradient of the graph is a force, but which force? Which is the unbalanced, mean which produces the acceleration. So change of momentum, unbalanced force times t, mean the unbalanced forces, change of momentum divided by time. So very, very important relation. F is equal to change of momentum divided by time. So we can write it rate of change of momentum is called force. This is the definition of the force in this chapter in AS. rate of change of momentum is called force. But when the statement is rate of change of momentum is an unbalanced force, resultant force, then this is called definition of Newton's second law. So now we have to define Newton's second law as the rate of change of momentum is an unbalanced force. Okay, according to Newton's second law, F resultant force is equal to ma. And this resultant force, this unbalanced force, is actually the difference of driving force minus resistive force. So this resultant force, this unbalanced force, F is equal to ma, can be written as m times change in velocity divided by time. Because acceleration is the rate of change of velocity. Now, F is equal to m times delta V over T. Now, m times delta V is the change of momentum divided by time. Look, this F is equal to ma is converted into F is equal to change of momentum over time. So these are the two equations for the Newton's second law. Now, there are two kinds of the forces. I'm not saying the types, kinds of the forces. Number one is the balanced force. Balanced force is a force which cannot produce acceleration. So acceleration, the object is zero, mean the object is either at the rest or moving with uniform velocity. Mean either the momentum is zero, object is at rest, or if the object is moving with a uniform velocity, the momentum mv is constant. So in these two situations, momentum is constant, not changing, or momentum is not there, momentum is zero, then the forces are balanced. But the second kind is unbalanced force. So here, the acceleration is not zero. Either it is positive acceleration, it can be negative acceleration, it can be centripetal acceleration. Because the momentum is changing, velocity is changing due to positive acceleration, velocity changing due to negative acceleration, and the velocity changing due to change of direction. So acceleration is not zero, it has some value, positive, negative, or centripetal. So the change in momentum is there, m times delta V, which is also force times T. So this is the unbalanced force. So there are two types of the two kinds of the forces. One is the balanced and other is the unbalanced. In the balanced, either no momentum or the momentum is constant, but when the momentum is changing, there will be unbalanced forces. So the change of the momentum is due to the unbalanced force. Now, if this time, I mean the time of application of the force, unbalanced force, is approximately equal to your reaction time, I mean very, very small, 0.2 second, 0.15 second like this, then the change of the momentum is called impulse. And the force is called, the unbalanced force is called impulsive force. But the condition is the time must be close to your reaction time, either equal or smaller than this. Then the change of momentum is the impulse, and the force is called impulsive force. Okay, this unbalanced force is related with the Newton's second law. But this balanced force is related with the Newton's first law. The object is at rest or moving with a uniform velocity. So we can define this Newton's first law as, in the absence of any unbalanced force, object will continue its state of rest or of uniform velocity. So this is the statement, this is the definition of the Newton's first law. We can define as object will continue its state of rest or of uniform velocity until an unbalanced force act on it, or in the absence of any unbalanced force, the object will continue its state of rest or of uniform velocity. So this is Newton's first law. Or the Newton's first law of motion. Now, the object has ability to resist against the change of the state. So ability of the body to resist against the change of its state. For example, if we change the rest into motion, or motion into the rest, we have to apply unbalanced force. Otherwise, the object at rest will continue rest. Object at uniform motion will continue its motion. It means we have to apply the unbalanced force to convert rest into motion or motion to rest. During the change of the state, the object will resist against the change, and this ability is called inertia, which is totally dependent on the mass of the object. It's not a physical quantity because it cannot be measured. We can compare only on the basis of the mass. So inertia has no unit. It is not a physical quantity. It's ability to resist against the change of the state. It is only compared, not measured. More mass, more inertia. Less mass, less inertia. And this law, the Newton's first law, object will continue its state of rest or of uniform velocity, sometimes also known as law of inertia. Because when we will change the state of the object, the first it will resist against the change of the state. But if the force is unbalanced, mean the applied force is greater than the resistive forces, then the object will change its state. So the Newton's first law is also called the law of inertia. So first law about the balanced forces, and the second law about the unbalanced forces. So in the Newton's second law, F is equal to ma, which can be written as m times change in velocity divided by t, are change of momentum divided by t. Mean for the change of momentum, unbalanced force is required, acceleration is produced. Now, when the object has momentum, it has speed, it has velocities, it has kinetic energy. And the formula for the kinetic energy is equal to mv square. And due to velocity, it has momentum. P is equal to mv. So we can write kinetic energy is equal to 1 by 2m times velocity speed from this. V is equal to P divided by m. So P divided by m whole square. Instead of V, we will write P by m, momentum divided by mass. So it is 1 by 2m P square over m square. 1m cancel. So there is another relation of the momentum. It is related to kinetic energy. It is P square over 2m. Kinetic energy is equal to P square over 2m. Now, if the graph is plotted between the mass and the momentum square, Newton's second whole square, it will be a straight line passing through the region or any graph, but the gradient of the graph will be 1 divided by okay, this formula can also be written as kinetic energy times 2m is equal to momentum square. So when the graph is plotted between momentum square and the kinetic energy at the y-axis, then the gradient of the graph will be 1 divided by 2m. And if the graph is kinetic energy at the x-axis and the momentum square at the y-axis, then the gradient of the graph will be 2m. Okay, this equation, this one. If the momentum, instead of the momentum square at the x-axis and the kinetic energy at the y-axis, when the graph is plotted, it's not a straight line, it's a curve. And the gradient at any point will give you 1 divided by 2m, mean the mass will be equal to 1 divided by 2 times gradient at that point.